Welcome to temperature and density. These are both pretty short sections. So, temperature is measured in one of three systems: Fahrenheit, Celsius, or Kelvin. Technically there's another one called Rankine, but we're not going to use that one. So, the Fahrenheit scale is, of course, the scale that we use in the United States. So, in the Fahrenheit scale, water freezes at 32 degrees Fahrenheit, and it boils at 212 degrees Fahrenheit. Notice that the water boils 180 degrees from where it freezes. That's how the Fahrenheit scale has been defined, as that separation is 180 degrees. With the Celsius scale, water freezes at 0 and boils at 100. This is a little bit easier to remember, those 2 points, but it also changes the size of 1 degree, because instead of 180 degrees difference, we now only have 100 degrees difference between the 2 points. And then we have Kelvin. So Kelvin is what we generally use in science, and there water freezes at 273.15 Kelvin, and water boils at 373.15 Kelvin. Note that the size of a Kelvin is the same as the size of 1 degree Celsius. Also note that it's not degrees Kelvin, it's just Kelvin. So it's kelvins and degrees Fahrenheit and degrees Celsius. So the size of 1 Kelvin is the same as the size of 1 degree Celsius, but the 0 point is significantly lower. So all of the Kelvin numbers, all the Kelvin temperatures are going to be higher by 273.15. So temperatures can be converted from one scale to another. If we have our temperature in, if we want the temperature in Kelvin and we know the temperature in Celsius, well, we just add 273.15. If we want to go the other way, if we want to get 2 Celsius from Kelvin, well, we move 273.15 to the other side, so we subtract 273.15 from Kelvin to give us Celsius. On the other hand, if we want degrees Fahrenheit from our temperature in degrees Celsius, well, we need to multiply by 9 degrees Fahrenheit divided by 5 degrees Celsius. This is coming from that 180 divided by 100, 180 degrees for degrees Fahrenheit between the water freezing and boiling temperature, and 100 degrees in Celsius. Plus, then we need to add the 32 degrees Fahrenheit for where water is freezing. That's to get from Celsius to Fahrenheit. If we want to go the other way, we need to solve this for temperature in Celsius and plug in our temperature in Fahrenheit. So, for the human body, a fever of 108 degrees Fahrenheit is fatal. So what temperature is this in Celsius? Well, we know that we have this equation, but that gives us temperature in Fahrenheit given that we know temperature in Celsius, which we don't know. We know the temperature in Fahrenheit, so we need to solve this for Celsius. So our temperature in Celsius, I've done the math, you can convince yourself that this is true, is equal to temperature in Fahrenheit minus 32 degrees Fahrenheit times 5 degrees Celsius divided by 9 degrees Fahrenheit, which is equal to, in this case, 108 degrees Fahrenheit minus 32 times that quantity times 5 degrees C over 5 degrees Fahrenheit, and that equals 42.2 degrees Celsius. Note that normal body temperature, 98.6 degrees Fahrenheit, is equal to 37 degrees Celsius. So if we raise your body temperature by about 10 degrees Fahrenheit, or about 5 degrees, just a little over 5 degrees Celsius, then your body will die. So you want to try to avoid that if possible. So if we want to look at another example, liquid nitrogen at 1 atmosphere boils at 77 Kelvin, again, not degrees Kelvin, and we want to know what temperature this is in Celsius. Well, we know that the temperature in Kelvin is equal to the temperature in Celsius plus 273.15, which means that the temperature in Celsius is equal to the temperature in Kelvin minus 273.15. So that's 77 minus 273.15, which gives us minus 196 degrees Celsius. So nitrogen, which is 80% of the air that we breathe, boils at minus 196 degrees Celsius. Now, of course, if we wish to, we could convert from degrees Celsius to degrees Fahrenheit, and that's an even larger negative number, but of course the temperature is the same. And we're just calling it a larger negative number in Fahrenheit because the size of a degree is different. That's really cool. So now let's look at density. You should be, I hope, familiar with density. Density is the ratio between the mass and the volume of an object. So density equals mass over volume. So if we want to calculate the density of lead, given that 246.9 grams of lead occupies 21.77 milliliters, well, we know density equals mass over volume, so we plug in our mass, 246.9 grams, divided by our volume, 21.77 milliliters, and we end up with 11.34, and now we need to have our units. So we have grams divided by milliliters there, so we need grams divided by milliliters here. So again, we're going to have a unit of mass, grams, divided by a unit of volume, milliliters. Note that these are not the SI fundamental units, they're prefixed, right? Remember, the SI fundamental unit for mass is kilogram, and for volume is meter. Sorry, that's not a fundamental unit, that's a derived unit, but that's the base unit, is liters. So that was temperature and density.